Okay, let me put this kind of in perspective for you. So, where's my magic pen? There it is. Okay, so we talked a couple days ago on Wednesday. We talked about absolute value functions in vertex form, right? So with vertex form, all this is doing is it's taking the stuff we learned when we talked about transformations, and it's just kind of repackaging it a little bit. Let's get rid of earbuds and all that crazy stuff. I don't want any distractions. I want you to get all this. We're getting near the end, right? We got 2 weeks, actually less than 2 weeks, till the end of the semester. We just have to be able to identify what are the values of A, H, and K. Those are the three numbers that are always going to show up in vertex form, right? H is the number that's being subtracted from X inside the function. K is the number that's added outside the function. A is the number that's being multiplied by the function. H and K represent the vertex for any function that has a vertex. A always represents the shape of the function. It's the vertical dilation factor, how much it's vertically stretched or compressed or reflected if it's negative, right? This is the way it looked for vertex form. It looks the same for absolute value function. I'm sorry. It looks the same for a quadratic function. Vertex form looks almost identical. The only difference being that instead of absolute value bars, we've got an x minus h quantity squared, but the h is still being subtracted from the x inside the function. On Wednesday, that meant inside the function meant inside the absolute value bars. Today, inside the function means inside the squared, right? It's inside whatever is being squared because it's a quadratic function. The parent graph is just f of x or y equals x squared. Just like before, hk, the ordered pair hk represents the coordinates of the vertex. The axis of symmetry is still the vertical line that splits the parabola in two equal parts, and it's going to be x equals h for any function that has a vertex. And just like before, a determines the width and the direction. That's the vertical dilation factor. Are we taking our regular x squared parent graph and changing its shape at all? So one thing that we always kind of just a quick rule of thumb, if the vertical dilation factor A is positive, greater than 0, then the parabola is always opening up. If it's negative, the parabola is opening down, right? Okay, so let's just work through a couple quick examples. I've only really got 2 examples today, and then you'll have some time to work. So here's a function, a quadratic function in vertex form. First of all, can you tell me what are the values of A, H, and K? And let's start with H and K, because those are the easiest. What's the value of H? Mr. Davis, what do you think? What's being subtracted from X?
7.
Almost. But what's slightly different?
-7.
-7, right? Okay, and this is the one, remember, the H is the one that's always going to be opposite of whatever that operation is right there. It's always going to be the opposite of that because it's being subtracted, right? So if it's an x plus 7 inside the function, H is -7. Okay, now K is simpler. What's K? -5. So those are the coordinates of the vertex, right? What's the value of A? 3. Good. So this function is being stretched, so it's 3 times as tall as it normally would be. Okay? If the coordinates of the vertex are -7, -5, then we know that the axis of symmetry is just x equals whatever the x coordinate is. That's h, right? X equals -7. That's our vertical line that divides it into 2 equal pieces. All right, let's try an example. How about one like this? Come on. Well, that's not working very well. What's doing that? There we go. Okay, what about for this? Try to get over there, actually. For this function, for f of x. Okay, first of all, we need to figure out, just write down what are the values of a, h, and k. What's h? -2. Good. What's k? 0. Nothing's being added outside. And what's a? Not 0, because it's being multiplied. 1. There you go. 1. Okay, so the shape is not changing, right? We're multiplying the normal heights by 1, which doesn't change them at all. And this is the vertex, so we just have to take this normal parabola and drag it over to there, and we're done, right? Because we're not changing the shape. Now, what is the shape, though? Let's look at the shape real quick. So the shape is the parabola y equals x squared. Right, so then starting from the vertex, well, the vertex normally would be at 0, 0, right, for our parent graph. If we go 1 to the right, we're going to go up 1 squared. That's how we're calculating the y values. If we go 2 to the right from the vertex, we go up how far? 4, 2 squared. If we go 3 to the right, we go up 9, etc., right? That gives us the shapes of it gives us the heights of all the distances from the origin, right, that we'd use to graph our parent graph. And that's what we got right here. Over 1, up 1. Over 2, up 4. Over 3, up 9. Okay, nothing's changed. That's our answer. Okay? And then the axis of symmetry would just be the line that splits this thing. There we go. It just goes right down the gut, right down the middle, right? Splits it in two. Okay, the kinds of questions you're going to be asked on the assignment, there's our picture we just drew, are things like this. Okay, it's going to ask you, what is that, six questions about this. And once you've done one of them, they're all about the same. They're all pretty easy, right? Once you know A, H, and K. So first one, let's just color code these here. So first one, what's the vertex? Well, we already answered that. The vertex is -2, 0, right? Okay, what about B? The axis of symmetry. Whoops, B. We already answered that. That's just the line x equals, if it's a vertical line, it's always x equals whatever all the x coordinates are. -2, right? How about the domain? That could not be easier because it's always the same answer for every parabola. What's the domain? If I zoom out infinitely far, what are all the x values contained? Infinity, right? It's all reals. So the domain. -infinity to infinity, right? The range. So the range is the set of all the y values. Now let's think about this. There's only one of two things that could happen. If the parabola opens up, the vertex is its minimum, right? It's a valley, so that's the lowest the ant could ever walk on the whole function, if it opens up. If the parabola opens down, the vertex isn't a valley, what is it? It's a mountain or a peak, right? So it's the highest you can go, right? So it's a maximum. In this case, it opens up. So what's the range going to be? What's the set of all the possible y values that the ant could ever stand on? We'll write it as an inequality first. Y is what in this case? Greater than or equal to 0, right? That's the lowest the ant could ever go. So greater than or equal to 0, right? Because it opens up. What if it opened down? What would the range have been?
Y is greater than equal to 0.
If it opened down?
Or y equals less than
Less than or equal to 0 if it opened down, right? Whatever the y coordinate of the vertex is, whatever k is, it's always going to either be greater than or equal to that if it opens up, or less than or equal to that if it opens down. If we want to write that using interval notation, it would just look like that with a bracket around the 0, right? Because we're including it. Okay? Give me thumbs. How we doing? Okay? So there's range. The largest open interval over which the function is increasing. Okay, again, just depends if the one of two things is going to happen every time. If we've got a function if I've got a function that's opening up like that, then the function's going to be increasing as the ant leaves the vertex. If an ant's walking in the positive x direction, it's always going to be increasing for the values of x greater than h, greater than the x coordinate of the vertex, right? It would be increasing there, right? Now, if we've got a function that's opening down, it's going to be the opposite. Now the function's going to be increasing to the left of the vertex, right? Because now the ant's always walking in the positive x direction. He'd be walking uphill until he gets to the vertex. Agreed? Okay, so for our function then, where is our function increasing? You tell me specifically. When x is what?
-2.
Okay, but -2 is not the answer. It's a part of the answer. The function's increasing when x is what? Say it again. True, but I want the set of all the possible values. The interval where the ant would be walking uphill. What do you think, Lucas?
Greater than -2.
Greater than -2. Everybody see that? This is the part where the ant's walking uphill. So that means that's the increasing part of the function. So it's increasing on the interval when x is greater than -2. Or if we want to write it using interval notation, which we probably should, it would just look like that. Right? Okay, how about the last part then? The function is decreasing on what interval? Well, if the parabola opens up, the function's going to decrease to the left of the vertex, and if it opens down, the function's going to decrease to the right of the vertex, right? Okay. So on our function, it's decreasing all the way from -infinity up to that point. So what's that going to look like as an interval?
X is less than
-infinity to -2 with parentheses, because I'm not including the -2, right? -2 is the bottom of the valley, so the ant's neither increasing nor decreasing at the bottom. That's when he's transitioning from decreasing to increasing, right? Okay, give me thumbs. Okay? Okay. All right, let's try a little tougher one, and then I'm going to let you work. So what about this guy? So I need the values of A, H, and K first. So somebody tell me, what's the value of A? Okay, good. That's the value out front. What's the value of H? Jackson? -1. Value of k? -2. Okay, so then that means, I'm going to scoot this stuff down a little bit. First thing we're going to do is locate the vertex. So I'm going to drag this over to coordinates -1, -2. Okay, now what about A? A is -1/2. What's the negative part telling us?
That's negative.
It's negative. Okay, what's that tell us about the shape of the graph?
It's going down.
It's going down, opens down. What about the 1/2? What's that tell us?
It's halfway to -2.
No, what's the 1/2 part tell us? The vertical dilation factor. What's that do? That controls the stretch or the compression, right? What's that tell us? The negative tells us it's going down. What about the 1/2? Is it getting stretched or compressed?
Press.
Getting compressed, isn't it?
It's
We're
negative.
multiplying the heights by a number less than 1. It's negative just means it opens down, right?
Oh yeah.
So the heights are only going to be half as big as they would for the parent graph. Agreed? Okay? So then we got to find, we always want to start with our parent graph, right? Remember that. The shape of the parent graph is where we start, and we're going to tweak that based on whatever the vertical dilation factor is. So this is the parent height. This represents the parent heights. We need to figure out what are the dilated heights going to be in our final answer. Okay? So we got a couple options here. We could use, there's some different heights we could use depending on which is the most convenient. If A, we're multiplying the heights by -1/2. That's what we do. We multiply the parent heights by A to calculate the dilated heights. Which one would be more convenient? To use the height over 1, up 1, or over 2, up 4? Over 2 up 4 would be better, wouldn't it? Because 4 is compatible with the fraction -1/2, meaning if I multiply them, I don't get a fraction. I get something simpler, right? So let's use that one. Let's go over 2 and up 2. So my parent height equals 2. Or sorry, equals 4, not 2. Right, I'm going up by 4. What's my dilated height going to be then? Over 2 and down to, everybody see it's going to be -2? How do I get that? Yeah, what's the recipe? I multiply the parent height by A to get the dilated height, right? So again, our recipe is dilated height equals A times parent height. Okay, so for us, that's equal to -1/2 times 4, right? -1/2 times 4 is -2. So I'm going to go over 2 and down 2. Give me thumbs on that. Does that make sense? Okay. So then we get points. I get a point. There's my vertex. There's another point. And I'm just going to create my parabola from those points. But that's a 2-for-1 deal, right? I know that I can reflect over the axis of symmetry to get a free point on the other side. deflect over to there. This one's 2 to the right, so this one's 2 to the left. And now there's my shape. Okay, so when you're doing these on the assignment, there's 2 different kinds of graphing tools that you end up using. One of them, here I'm going to type these so it's easier for you guys to read. This will look familiar. On one of them, you've seen both of these, I'm sure. On one of them, you click on the type of shape you want. So in this case, we'd be clicking on a parabola. And then here's what it does. It's going to give you some options. It'll say things like, I think the options, they go in this order. I think one of them is vertical stretch. And it always starts off as 1, right? And then over on the other side, I think it says horizontal stretch, and that always starts off as 1. Okay, you're never going to change that one. We're not learning about how to do horizontal dilations. That's really not a big. If you can do vertical dilations, you don't really need to do horizontal dilations. So we're not even messing with that. So that one's always going to stay as 1. Okay, is that emphatic enough for you? And then down below, it says vertical shift. Is that right? Raise your hand if you've seen one of these. Seen one like this? Okay. And it always starts off as 0. And then it says horizontal shift. And it starts off as 0, right? And all you've got to do, you're going to click on like the parabola tool and just click anywhere on the graph. It doesn't matter. It's just going to start it at the origin. And then all you have to do is pick the right values and close the box, and it'll graph it for you. So those are super easy, right? So for this one up here, what would we do? Which changes would we make? What would the vertical stretch become for our function? What would it be? -1/2. That's all it's asking for is A, right? That's the job of the vertical dilation factor, okay? So we would just replace the 1 down here. We'd replace that with a -1/2. What's the horizontal, or what's the vertical shift based on our vertex? Everybody agree? -2? That's just going to be K every time. Okay, so we replace the 0 with the -2. And the horizontal shift would just be -1, wouldn't it? That's the x-coordinate of the vertex. That's h. So we replace that with a -1. Okay, the other type is the one I prefer, is the one where you actually have to draw the parabola. And all you would do with that is you would start, the first step would be, you're going to put a point at the vertex, right? And then you have to define one other point, and it'll shape the parabola to fit that other point. So then the second point you would pick in this case is the one that's over 2 and down 2. And then it'll make the parabola look right. Make sense? Start with the vertex, and then you drag another point out. Okay, questions? All right, I'm going to let you work. Go to work.